Okay, so let's go for the first part, Introduction to Computer Science, first lecture. Okay, what is the objective of this? I think it's related to chapter 1 and 2 in your textbook. There's nothing to write down yet, I guess. But it's okay, it's up to you. But usually I say not meaningful stuff. So it's up to you. Objective, the definition of computer science. Definition of computer science, I briefly mentioned last class as well. It's not going to be a programming. It's not, it's a common misconceptions that people have. Computer science courses only teach programming. No, they teach something else. Something called algorithms. Algorithms. We're going to take a look at what is algorithm is. I guess it's first class and first few chapters in your textbook, they discuss most conceptions. Like, what is it? What way of thinking we should have. So it's not going to be too much difficult, too much techniques yet. It will come in next few chapters. Brief history of computing. But I don't care too much about histories. So most likely I'll be skipping some of the part. Okay, let's take a look on what's in it. Am I speaking too fast? 영어를 너무 잘해서. Okay. I feel like I'm speaking too fast. Or am I moving too much? This is my thing. I'll be moving around all the time. I cannot help it. I try to fix myself, but it's not going to happen. So I know it may get dizzy at some time, but just stay with me. Introduction, misconceptions. Computer science is a study of computers. Yes and no. Is there a lot of things to study about computer itself? Do you ever care about CPUs? You just simply use it, right? So it's not about computer itself. Well, if you're into computer engineering, you might be concerned with some of the hardware's techniques using their computer science. It's a science. What is it between? What is the difference between science and engineering? What is science? What is science? Theory. Yes, half and half. Engineering. What is engineering? You guys into School of Engineering, right? 공대 아닌가 우리? It is. What is engineering? 응용. Yes. Science usually study for phenomena in nature. So you look at stuff, you wonder why that happens. So you study why that happens. You try to figure out how it happens, and probably that's it. So a lot of measurement, monitoring. You take a look at it for a long time. You record and try to understand. It's a study of understanding. Engineering, in fact, based on the scientific fact they found, they try to build certain applications. So it's make it better. So engineering, building bridge, building computers. So computer science, right? It's not matching. Computer is not a science. I mean, in old factory, we don't do any of laboratories, but it's still called as science. So there are some of the misconceptions like this. Study of how to write a computer programming. Yes and no. Yes and no. But it's not all about programming. That's why in the first class in the introductory, I was saying, if you don't have any programming background, you shouldn't be worried. Shouldn't be worried. Like myself, I didn't have any idea what programming was. So it doesn't matter. Later, you will see that even if you don't have any programming experience, writing a program is not about knowing the language. It's about changing how you think. It's much easier to write after that. So we're not going to write down the code in here. I'm sure the other courses will cover that, teach you how to do a very basic techniques to write a program. So it's not for us, at least in this course. Oh, shoot. Already I'm getting tired. It's a difference between first year, second year students. You guys looking at me all the time for at least a week or so. Second years, they don't look at me. They usually sleep. You guys will be like that in a few weeks, but like 50 eyes looking at me at this moment, it's very scary. So don't look at me, look at each other or something else. So it's not a study of use and applications, computer and softwares. My experience, because I didn't know nothing about computers when I actually went into this computer science courses in my university. So my first course was teaching me how to do a Excel. Back then, the Mac, I don't know you guys have seen it, the new Mac came out. Very weird looking, very pretty computers were out. We actually had to use it writing a small programs on top of Excels and Word. But it's actual computer science is not about that. I mean, that's for non-major people who's not into this area. And plus, you guys know how to use a program. It's so easy to install a program nowadays in anywhere. Anybody here have experience in installing the operating system other than Windows? Okay, what was it? Linux. Anybody have tried? I know you guys are busy in high school, 공부하느라 수능 all the time. But if you back then installing such operating system like Linux, we heard about it, right? It's on the news. And even though we never seen it before, I believe most of you just Windows people. Back then, it was very difficult to install such operating systems. Windows was much easier. That's why it was so popular, even now. But Linux gets better nowadays, so much easier too. Just simply click, you can install it. So we're not going to teach you how to do that. So that's a general misconceptions that people usually have. And after a couple of classes, if your friends or if your parents asking you to fix a computer, you say no. I'm not learning this such stuff in school. Okay, you can say no. I still get a request from my friends and my family. Please fix my computer. You're teaching a computer science courses in school. I usually just fix it because it's just too tired of explaining. It's not computer science, but you can say it from this point. So somehow, a lot of computer science courses is being taught with the mathematics because computer science is actually from mathematics. Well, there is a lot of areas within the mathematics too, right? I don't know about 수능. I didn't go to high school in here, so I don't know what you guys study in high school. But what do you guys probably study calculus? 미적분? Right? So some people do study from calculus or logics. There are many different algebras. Those people eventually comes down to this computer science areas. I'll tell you a little story later when we go into histories. But computer science is study of something called algorithms. Sometimes we hear this term here and there. 그죠? 알고리즘이라고 들어봤죠? Right? What it is. Including the formal and mathematical properties. If you have something called algorithms, it's actually just a procedure of doing stuff. Anybody has a calculator? Have you ever seen a graphical calculator? Oh, you guys are using it in high school? Cool. I was so dumb in high school. My high school never teach you how to do math in hands. So every single class, they have to give us a calculator. So even now, I cannot do any simple math without any calculators because I wasn't trained for like that. 그래서 더하기 빼기 할 때도 잘 못해서 거의 계산기로 많이 해요. So how can the calculator can add numbers? Is it a simple procedure? If I give you assignment to write a algorithm, write a procedure to add two numbers, can you write it down? How do you do it? So the process of writing down those steps of a problem solving is a algorithm. So sometimes they do require formal definitions. Formal means, we'll go into that anyways later. Mathematical properties like some calculators may be faster than the others. You can say they may have a better algorithms because they found a way doing stuff much faster than the other. Then it's not depends on the CPU or anything else. It depends on the algorithm performances. So how smart you are of doing stuff. So that's one property. The hardware realization, linguistic realization. You will see, why do you think it calls a programming languages? C sometimes called programming languages, C++, not sometimes. Everything is called languages, right? Later we're going to discuss natural languages and programming languages. Languages are very complex, right? Have you ever tried the Google Translator on the web page? It works quite nice nowadays, quite nice. But if you try to translate very weird looking Koreans, like things that we only speak about, 이상한 말, 무슨 두 번, 세 번 꼬아서 하는 말, 이상한 말. Have you tried to translate those into English? They're not going to translate good, right? So the language is quite complex. And computers, the humans build a programming languages to make computers to understand what we try to say. So it has to be simpler than what we speak. And applications of algorithms. Where do you see this? Everything is algorithmic based. I cannot think of good ones, but the recent stories that I heard. Anybody buying a lottery tickets every week? 복권 사는 사람. Lottery tickets. Amazingly, a similar lottery ticket is being sold in the US every week, but not every week have a winner. But in this country, we have at least 10 to 15 winners per week, right? 그지? 미국은 한 달을 해도 한 번도 맞는 사람이 안 나오는데 우리는 20명씩 나오잖아 매주. 그죠? 로터리 1등 맞아봐야 얼마 안 주죠 요즘에는. 물론 맞으면 좋겠지만 맞아 안 주죠. So algorithms to produce those numbers. When you pay 5,000 wons to get 5 numbers out, what kind of algorithm is running on top of that small machines to produce a unique numbers for everyone? So we can have just only one winner all the time. Right? Have you ever thought about that? Maybe. No one buys a lottery. Maybe you guys are too young. I try to buy one every week. As soon as I won the first place, I would quit this job and maybe not. But so everything that you see and every living, everything that you use have algorithms in it. So that's brief definition of computer science. It's just too broad, but you can write it down into a few one of those. So continued algorithm step-by-step method. I know not many of you have a program experience, but anybody heard something called BASIC? BASIC, 어떤 사람? Right. BASIC, it's also a very, or MS-DOS. It's my problem. The gap between you and me is keep getting bigger and bigger every single year. So examples that I know, you guys never seen it before because you guys weren't born or were too young to know those stuff. Anyway, if you try to take a look at some stupid languages like BASIC, they actually write the program in this way. 10, 20, 30, 40, and they write it down the program in here. and it's being executed from top to bottom, step by step, step 10, step 20, step 30, step 40, this way. It's one of the simple way of doing it. Right? Algorithm, if you put it, it's that step by step of writing down the stuff to solve a certain problems, some task. I'll come back to that. Operations that used to construct the algorithm. Operations that we need to know to write down these steps. There are 3 different operations. Well, there are more, but 3 big ones. Sequential operations. What is a sequential? What does it mean to, in dictionary? I don't know. In Korean, what is sequential? 찾아봐. It's perfectly okay to use your smartphones. Just don't play games or don't play Kakao. Okay, between you guys, it's okay. Anybody have a laptop? It's perfectly okay to use it within class. I don't mind. Just 뭐 전화만 받지 마. Otherwise, it's okay. Right, sequential 순차 from top to bottom. Step 1, 2, 3, 4, 5, 6. That's a sequential operations. It's the first component. Next, conditional operations. Conditional operations. Let me write this down number in different ways. 2, 3, 4 steps. Sequential seems to be 1, 2, 3, 4, 5. Conditional, conditions. Conditions to go somewhere else. Maybe at line 3, they ask questions. If something is yes, go to line 10. If it's no, go to line 7 somewhere. Conditions, conditional statement. So if I jump off, then I don't go into here, right? Conditional operations are the second component of doing stuff. It's still very basic stuff. You guys know. I was surprised that everyone seems to know this notation, like, right? I don't know where you guys learned this. 이거 어디서 가르쳐줘? High school? Why do they teach you this in high school? I don't understand why. 무슨 과목? What? Ah. Stupid math teachers. Yeah, it's a very similar looking. 이렇게 보면 they have yes, no, right? It's a dumb looking. 뭐라 그러더라? 순서도? I don't even know what that is. I don't really care, but it's a very similar idea. In fact, it's exactly the same idea. Why does the math class teach you this? I guess it's also a logics, computer logics right there. So we discussed this about logic formal definitions and stuff, right? So it's from algebra. I don't know how to translate algebra into Korean, but one of the math areas, logical thinking, logical way of doing it. Next one, the last one here, iterative operations. So there's only one left, if you guys know this. What is it? 찍어. Iterative. Square. 이거. Okay. I'm not so sure what this does anyway. I forgot actually. I forgot what it does. 다시 한번 얘기하지만 무식해요. 고등학교 안 나와서 여러분들 아는 거 잘 몰라. 그래서 알려줘야 돼. That's why I let you use the dictionaries, computers. Sometimes I forgot the word, so I'm asking you. Anyways. The third one, square, okay. But if I'm using a square, I might do this. What is it? In here, maybe line 2 to 5. I repeat 2 times, maybe. Like loops, something called. So I have to do certain tasks over and over again for a few times. Maybe that's another operations that you can have. Well, even with those 3 basic operations, you can start write the algorithms of your own. Very simple ones, of course. But it's a basic component that you can think of. Of course, later they will have very difficult ones, but at this point, this is good enough. So step-by-step method for accomplishing solving problems of using these 3 different formats. So simply put as, what is my algorithm to walk from my office to this classroom? I don't know. Lock my door, walk, 5 seconds, open the door in my building, close the door, walk another 10 seconds, open the door in ITBT building, turn right, turn left, open up the door here, 5 more steps, standing up, turning up the computers, steps. The things that I just did, if you write it down, because I'm gonna do the same operation at least 2.5 months. 그지? 학기가 2달 반, 3달이니까. So write it down, it might be easier later. That's it. Programming is nothing more than that. Programming is nothing more than that. Only thing you left to do is you write it down this and just translate into, if you really want it to be a written program, you're going to translate this steps into a programming language. So without this, you cannot even start any programs. So I don't know, maybe one of the assignments I would give you is programming. When I was doing it, the often common mistake that people make first years was when they given a programming assignment, they start sitting in front of a computer and try to write it right away. But you can't start because you don't know where to start because you don't have an algorithm to begin with. Right? So for the first step, in order to do a programming, you don't need the computers. You just need a sheet of paper and maybe a pencil. Write it down, the steps that you're gonna build. 난 되게 지금 빨리 하는 것 같은데 좀 가라앉아야 되겠는데. 사적으로 얘기하면 초반엔 좀 쉬워요. 저는 뭐 뻔한 얘기를 이렇게 오래 하나 그렇게 느낄 텐데 그래도 어쩌겠어. 좀만 참아요. 좀 더 재밌는 게 나오겠지. So this is one of the examples. Your textbook actually give many examples of the algorithmic thinkings. They start from very simple, very dumb examples, problems. This one is for algorithm for programming your DVR, the video record, I think. Step 1, if the clock calendar not correctly set, go to page of something and fix it. Step 2, place a blank tape into the video record. Step 3, repeat step 4 to 7. I don't know what they try to do for each program that you wish to record. So 요즘에 이런 게 많이 없긴 한데. So there is a TV program that I wanted to watch, but I wasn't there. So I put the timer for my machines to record those programs when it's online. So it depends on how many programs that I wanted to record. I'm gonna repeat this step, 4 to 7. Probably asking for the numbers, time start, when you wanted to finish recording, and then if you do not wish to record anything else, then just end it. When you stop doing this step, go to step 8. Turn off your DVR. Your DVR is now timer mode, ready to record. Just go. Okay, this is very, very not a good format of algorithm. Still, we have a lot of word in it. Later, if I ask anything in algorithmic, something called pseudocode, I do not wish to see it like this. I wish to have a more concise, less word, more clear instructions. Like the step to place a blank tape into DVR slot. I would say put tape, something like that. Very simple steps, much more clear. The reason comes later. Why do you do not wish to have very unclear messages in your algorithm? This one is another algorithm. Start from a very simple calculator. It looks a bit formal looking now. It looks a bit more like mathematics. 약간 수학같이 보이죠. Just because it has symbols and inequality signs, but it's nothing more than this. What is your first math teacher in your life? Who was your first math teacher in your life? 초등학교. Yeah. What if we before elementary? I think my first ever math teacher was, I don't know, it's still around. 재능수학? Is it still around? It's the one person comes to my house every week with a couple exam papers. They teach you that. They teach you 3 years old kids do this, right? 눈높이 뭐야? 요즘에 제일 뭐가 제일 유명해? I don't know. 재능 교육. One of the first thing they teach you is probably this. I don't remember much, but it's like. Right? After a few weeks, they probably start teaching 5. One. Isn't it? There are a set of questions like this. This is algorithm to do that. Right. This is the algorithm to do this. Human, we are smart. We don't need that algorithm. Our brain just do it right away. You know? But what if you try to do this with 1,000 numbers? Maybe the digit here is 1 million. Would you try with your hands and brains to add 1 million digit numbers? Is it going to be easy? Probably take forever to do this. Then maybe there's a chance that we use this algorithm to do that for 1 million times. Okay. Let's take a look. 재능 수학하니까 여러분들이 확 깨어난다. 역시 쉬운 걸 해야 확 깨어납니다. 정석 얘기하면 다시 자는 거고. 그죠? Algorithms for adding two m-digit numbers. m-digit numbers. 또 맛이 같구나. m-digit numbers. Given output. Given m is bigger than equal to 1. And two positive numbers, each containing m digits of am minus 1 to a0 and bm minus 1 to b0. They using a very weird notation, but it's all it is this. 분필을 어디다 갖다 놨지? Given m is okay. I'm adding two numbers like this. 맞나? Okay. And they wanted to have something called C. C might be needing another, maybe, right? Maybe there's another one comes. Maybe this is also possible. Digits, right? Assuming m here is 2, m2, then just pick any number with the 2 digits. 12 plus, 몰라, easy, 13. Here m is 2, am minus 1 is 1, a0 is 2. bm minus 1 is 1, b0 is 3. C, what is it, C then? C0 is 5, 2. C m minus 1, C0, So M is 2, C1, C0. I just explained 재능 수학 into very complex ways. It's nothing more than this. But what is the problem with this algorithm? Not the problem. What is the thing that you should look for? Why do you think I show you 2 examples in here? Because of this, there may be a carry bits, extra bits happening. So you have to move to the next digit to add it up, right? We can do this with our brain, but how are you going to explain that into an algorithm? So that's the key part in this algorithm. So step 1, so I'm giving A's and B's. Algorithm start from step 1. Set value carry to 0. Carry here means any number that is happening up here. So there's nothing to add yet, so carry is 0. Carry may be always 1 or 0. 그죠? So that's carry bit. Set the value of I to 0. I'm going to do how many digits in there. So I'm going to say, I think, AI. Numbers keep growing. I equal to 0, while the value of I is less than equal to n minus 1. I starting from 0, if it's a 2-digit, then 0, 1. There's no 2. So I'm going to explain anyway. So repeat the instruction from 4 to 6. Let's go to 4. Add 2 digits, A, I, and BI. It's I start from 0. A0, B0, add. Makes sense, yeah? And the current value of carry to get to CI. So there will be a CI. If carry happens, I'm going to write it right here, either 0 or 1. Okay. If CI is 10, 1, 0, because let's say A0, B0, 4 plus 6 is 10. If it's 10, then reset CI to CI minus 10. So if it's 4 plus 6, I'm going to set it to 10, and then they say I'm going to subtract 10, somewhat. And then reset the value of carry to 1. Carry bits will be 1. And what else? I'm going to add the carry bits to A2, B2. Repeating the steps over and over again until I reach this point. And then if I hit that point, then I'm going to just quit and print out the final values of C. Because I'm keep recording C1, CI, C0, C1, C2, this way. So. And then you have your answers printing out like this. Very simple examples. But if I ask you to write an algorithm of doing that without giving you this, you will write a very funny algorithms of doing stuff. You'll be forgotten. In Korean briefly. 주고 보니까 되게 쉬워 보이지? 되게 우습잖아요. 내가 예를 들어 이걸 안 주고, 책에 이걸 안 주고, 이걸 할 수 있는 알고리즘을 적어오세요 하면 희한한 알고리즘이 나오기 시작할 겁니다. 캐리가 막 100이 되고, 캐리도 없고, 막 난리가 나는 알고리즘이 각자 장담하는데 여기 50명인데 50개가 다 틀리게 날라올 거예요. Easier in your brain because we're trained to do this. So we're doing it so fast in our brain. But you actually try to translate into that stepwise functions. It's not that easy. That's why you need a practice. Practice. It's not something that you can be taught. Something that you have to spend time and try to think in different ways and try to write it down. So a lot of assignment questions, even in the exams, I'm going to give you examples like this. Maybe I delete step 4 to 7 and ask you to write the missing steps of that part. It's one of the the simplest problem that you will be solving. 이거 못하면 안 되겠지 이거. Another advice. 아니다 그건 나중에. Algorithm for adding two m-digit numbers. So doesn't matter later. Doesn't matter how many bits that I have. With this algorithm, I'll be able to do a million-digit addition. 그지? Right? Because I'm gonna set m equal to million. That's the beauty of algorithms. You can reapply, automate the process, even for big numbers in this case. Hopefully you can see the power of an algorithm from this very simple examples. Okay, maybe I would do that too. So, okay, now I have an algorithm. How can I write a program on that? I'm gonna just do it very shortly. Okay. Even though I don't know nothing about programming. But I think I know how to do this. I write it down. How can I translate this? Maybe I just do it in the same. Step 1 says set value of carry to 0. Okay. I don't know too much about C, but I think I see like integer carry 0. The first line of your maybe C or any program. Okay. Set the value of I to 0. Integer I 0. Right? Third step says while the value of I is less than or equal to m minus 1. They didn't say it in here because we didn't say it. Let's say, I'm gonna say m, what's your number? Just pick one. 아무거나. 5, okay. 5. Okay, again, step 3, while the value of I is less than or equal to m minus 1. Okay. While I is less than equal to m minus 1. While I'm in this condition, I'll be doing step 4 to 6. Simply translate step 4. Where else are there? Digit AI and BI, okay. CI equal to AI plus BI. You're halfway done. You just write your first program. This one probably for the C, right? That's why we don't teach you how to do a program. You will learn yourself, and other courses do this syntax. Just like our language, it's a grammar. We speak based on the grammar. 그렇죠? 문법에 맞춰서 얘기하죠. Well, it's not always true, but English, Korean also have grammar. Computer languages also have grammar to follow. We just simply translate that into computer language according to their own grammar. Right? So if you do have this, you're 90% done. You just simply translate it to a language. Okay? Hopefully you can see the procedure now. What is the first step to write your own program or write your own algorithm? Okay. 너무 쉽지? 재능수학이 나오다니. 대학교 첫 수업에서 재능수학이 나오다니. 그죠? 1 더하기 1을 가르쳐주고 있다니. Surprisingly, some of you are built this way. It was so difficult to think like this for many years. But some people are just born with it. 어떤 사람들은 이게 딱 체질에 맞는 사람들이 있어요. 안 해봐서 모르다가 딱 숙제내면 이거 난 금방 하는데? 이런 사람들이 나와요. 한 30%는 그럴 거예요. 여러분 중에. 나머지 한 10%는 평생 봐도 모르는. 왜냐면 머리가 그렇게 굳어갖고 나는 그 10% 안에 들었어요. 지금도 쉽지 않아요. 프로그램을 잘하는 사람들이 이렇게 나눠 이렇게 보거든요. 이 프로그램을 잘한다기보다는 문제를 잘 풀 줄 아는 주어진 문제를. 그런 사람들이 분명히 있을 겁니다. Hopefully you can discover yourself new ability that you never know before in your life with these assignment questions. So why are the formal algorithms are so important in computer science? Formal way of writing down, like this. It should be more formal, more concise, but one of the examples like this. Because if we can specify algorithm to solve a certain problem, then we can automate its solutions. You begin with the simple 1-digit, 2-digit addition. You can build up to 1 million digit addition program, right? It's automated. Everything will be automated. You don't have to do this. If you're clear with the algorithms, you can simply reuse it all the time. It will be much more correct, much more perfect. 사람이 하다 보면 실수할 수 있겠지? But is it going to make a mistake with the million digit numbers? With this algorithm, no. You will make a mistake, but this program will not make a mistake after a certain point. So computing agents, machine, robots, person, things carrying out the step of algorithms. You are also somewhat computers, your brain, CPU, your memory is somewhere in your brains. The machines also understand that algorithm will translate in right ways to explain what they should do. So you are an agent, computing agent, very smart computing agent. Computer, very dumb agent. We have to be very concise, stepwise. Again, algorithms, well-ordered collection of unambiguous and effective computable operations that, when executed, produces result halts in finite amount of time. How many of you understand this definition by just reading it? 감이 확 왔다. 이거 읽어보는데 난 벌써 이해 다 했다. Raise your hands. They use a very fancy terms, but it's not so much different from what we just discussed. Let me read it again. Well-ordered collection of unambiguous, effective operations. Well-ordered, nicely lined down 1, 2, 3, 4. Collection of unambiguous. What is unambiguous means? Clear. 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 Ambiguous means unclear. Unambiguous, clear. Because computers are dumb, we have to tell them exactly what they need to do. No ambiguity. Clear set of operations like these, add, declare variables, stuff. And if it's being executed, means it's being run, and should produce a result, C0 to Cm minus 1, and it should finish. It says halt in finite amount of time. Halt means stops in finite amount of time, given time. If it never stops, then it's not halting in finite amount of time. It runs forever, infinite times. So it's a somewhat more formal definition of algorithms. Of course, if you try to look for definitions of algorithms on the internet, there will be many. It's not the only one, and it's not that important. But these points are important. Has to finish, has to produce the output, and has to be unambiguous set of instructions. That's the 3 key things that you should know. What happens if it doesn't finish? What happens your program or any algorithm doesn't finish? Keeps running, yeah. How do you know it's keep running? It used to be, I usually bring it up as when you're doing a Windows, when you see a blue screen. Oh, well, blue screen, they keep running forever. It's not the only reason, but one of the cases. Because some program in running on Windows, there is some problem with the algorithm. It runs forever. It takes so much memory and CPU, running. At some point, the Windows, I cannot take this anymore. Let's die altogether. kill. If you want to think of that way, that's fine at this point. So, or you freeze your screen. Usually freezing, nothing respond. Usually that also related to this running forever. Of course, there are multiple issues of such phenomenon, but one of the easy ones that you can find. So you have seen all this type of very bad algorithms. Simply put, some programs are really bad. It means they have really bad algorithms, slow, freezing all the time. You can conclude that somehow. Ambiguous statement examples. Go back and do it again. Often, later I give you assignment, they actually try to write this way. Go back and do it again. It looks concise, looks very short, looks to be legitimate operations, but it's ambiguous because go back where? Do it again what? Has to be clear. Do line 4, that's clear. Go back line 2, that's clear. Okay? So there is a difference between writing in concise ways and making clear statements. Start over from where? Start from line 2, end in line 11. That's clear instructions. 이러다가 학기 중간에 목이 나가겠다. 그죠? 질문 없지 아직. 너무 쉬운 거여서. 그죠? 내가 이 교수님의 수준이 너무 낮다. 그러면 raise your hands. I will think about something else. Anytime, I will welcome to have a feedback. 쉬어가는 의미에서 대학교 오면 뭐 배울 거라고 생각했어? What do you expect to learn in universities? 맨날 drinking alcohols, beer, soju. I don't know what your expectations are. University courses, is it so much different from high school? I don't know. 고등학교 때 스타일이랑 많이 틀려요? 오, 그래? That's a good thing, right? You guys hate high schools. Anyways, that's a good thing. Eventually it will be very similar. But hopefully you can enjoy some different style. But if you're having a difficulty or have an opinion about styling, my teaching style or course material too easy, why are you teaching 1+1? I'm welcome to have those comments and feedbacks. Okay, unambiguous operations can be understood and carried out directly by computing agents, for example, your computers, without further simplification or explanation. It says primitive operations. Primitive operation. Primitive means very primitive, simple. Just once you see it, you know what it is. Like this, int m. M is integer. Integer is a value. Right? integer가 뭐야? 상수? 소수? 상수? 상수. M is integer. Clear. I don't need any other explanations. M equals 5. Do I need extra explanations for doing this? Primitive operations like this, clear. It's not enough for operation to be understandable. It must be doable. Doable while doing something. C A1 plus B. Doing something computable. It's doable, so it has to be understandable by agent, your computers. Algorithm continue. Result must be produced after execution of finite number of operations. How do you make sure the previous algorithm that we looked at terminate within finite number of times? How do you? What is a safety mechanism in this algorithm? How do you make sure we don't do this forever? Oh, our safety mechanism in here is we give a condition. I is less than equal to n minus 1. So as soon as somewhere in here I should say I plus 1. Every time I keep adding 1. At some point I will be bigger than n minus 1. As soon as I exit this block, I'm done. So this is my safety mechanism in here, this condition. If I do stupid things like, what might be the stupid things that I can do? Well, yeah, somewhat like that, I don't know. And then I start with the I is whatever 1. Then I keep getting bigger. No condition will stop this loop, right? Then you're into infinite loop. It will not produce any outputs at all. That's very important later. That's a common mistake that we will make. Infinite loops. It's called loop. Infinite loops. Running forever. How do you stop it from running forever? I mean, often the algorithm writers, they don't realize they made a mistake in their own algorithm because they think they're so smart. I will never make a mistake like the stupid ones. But you will make mistake like that. So what's the usual way of doing this? How to stop it? I don't know. For me, usually Control C, exit. Or in worst cases, power off. That's very radical approach. But things like, I don't know, if you go into Windows, 작업 관리자? Then you can see the programs running at the same time. Maybe you can click on the program that you wish to kill it. Right? Click and kill. Maybe that's one of the ways too. That's also okay too. Dumb way of doing it, but okay too. 나중에 되게 신기한 게 자기가 알고리즘을 이렇게 딱 써놓고 나면 자기는 뭘 잘못했는지 잘 보이지가 않아요. 이게 빠져갖고 내 건 완벽해. 근데 웃긴 건 친구가 지나가다가 슥 지나가다가 야, 너 여기 왜 이러냐? 그리고 슥 지나가면 그게 잘못돼 있어요. 똑같아요. 바둑 둘 때 훈수 두는 사람이 더 잘 보이지 똑같아요. 나중에 그런 경우가 비일비재해요. 그래서 친구들끼리 한 번씩 리뷰해 주는 것도 하나의 방법이 될 수가 있어요. 근데 이제 잘 그렇게 안 하지. 내 거 보고 베낄까 봐. 근데 괜찮아. Another example, dumb example after examples. Algorithm for shampooing your hair. I hope everyone wash their hairs in the morning, every single day. 설마 그러겠죠? So operation step 1, wet your hair. Put the water in. Set the value of wash count to 0. I need this because sometimes I forgot whether I wash my hair or not. 이거 하다가 sometimes, maybe did I just do a shampoo or not? So I just do it again, twice. It doesn't happen to you guys, it will. After you over 30, 40, you forgot. And sometimes I forgot I wash my teeth, I brush my teeth. So I have to do it twice. 웃지? 좀만 10년만 있어봐요. It will come to you anyways. So I need that too. Set the value of wash count to 0. Repeat step 4 to 6. The value of wash count is equal to 2. So it means just twice. Do it twice. Lather your hair, 거품, bubbles in your hairs. Rinse your hair, put the water in. Add 1 to wash count. Still, wash count is at this point is 1, but I'm still comparing to 2. Do it again. Add count is at this point 2. I did this twice. At this point, add wash count 2 equal to out. Stops. You have finished shampooing your hair. Good. So tomorrow, when you're in shower, you start thinking about writing algorithm for your shower procedures. I don't know. Might be one way to do a practice. But problem with that is just still too wordy. It means has many vocabularies in it. So this is good enough. Simpler. Step 1, wet your hair, lather your hair, rinse your hair, lather your hair, rinse your hair. Stop, you have finished shampooing. Looks very simpler, but there is one problem with this. What is it? Yeah. It says wanted to do it twice. So they should simply do this. Repeat themselves. Okay. Twice, 3 times, okay. 100 times. The number of line of instructions will grow, right? So another way of looking the power of iterative instructions. So, on the side, the electrical engineering people, 전자공학과, sometimes they prefer this. Sometimes they prefer this way of writing algorithm on their chips and stuff because in some cases this is faster in terms of microseconds and milliseconds because this is a bit more expensive operations. They have to access some other memory locations. They do have to do addition, comparison. Sometimes this is too much for smaller computers, smaller chips. So in other fields, they prefer that. But it looks very dumb. It's difficult to call it as a program. Right? It's difficult to call it as an algorithm. Importance of a algorithmic problem solving. Computer revolution of the 20th and 21st centuries have enabled us implement the algorithm to mechanize, automate, and repetitive mental task. Simply from this slide on, it's another way of saying it is computers are nowadays so much better. Our algorithms running much better. Back then, it was studied by mathematicians when they didn't have a good computers back then. So the only thing they can do is write it down, analyzing with their hands. But nowadays, computers, ever since 21st century, computers are so nice, we can actually practice. We can come up with a better algorithm to test on top of good computers. So it's much better now. One of the histories of the computer science, or before I go into this, next few set of slides is like this. 1940s, some crazy old guy developed something so nice. People used it. 1950s, some crazy old guy developed something, it's so nice. It's not high school. You don't need to memorize this. Don't worry. I'm just saying it because some people try to memorize this. I'm never going to ask you these questions in your exams. It's not high school anymore. 뭐 역사 과목도 아니고 안 물어봐요. 40년대에 누가 뭘 만들었고. I don't care. I do care what you have now. Okay? Other than this, why do you think computers has developed so much, algorithms developed so much last 50, 60 years? More than 60. What do they use for their first computers? 뭐였을까? Why did they? Because of the war, it was developed in war times. First World War, Second World War. First set of computers was built to calculate the bullet trajectory. Bullets here means 대포, 뭐 이런 거. They wanted to calculate this. What's the degree they should have? What's the velocity, speed they should put? Then how much it can go. Why do they need a computer with this? Because it's calculus. It's going a trajectory like this, so they had to calculate this. 정석에 맨날 나오는 거 아니야 이거, 그죠? Piecewise functions. You could do this with your hands, but they wanted to do this. And then it eventually go into used as simulations for nuclear weapons and stuff. Even before that, computer was, anybody heard the Alan Turing? Turing. There is a story. Apple's 뭐냐? Apple computer. 사과 어떻게 그려? 사과. Assume that's an Apple logo. Assume that's an Apple logo. There is a byte in it. Alan Turing is the guy who break the encryption code in the Nazis' encryption code in the war times. He's a very famous computer science, first generation of computer science mathematicians who did it. But this guy died. The story says he's committed suicide by having an apple with a 청산가리 chemicals. He killed himself. So Apple logo actually came up with admire his achievement. That's why Steve Jobs come up with this. I don't know whether that's true or not, but it's the story. The reason I'm bringing up the Alan Turing, back then he was also the first guy who get the idea of computers to solve a Nazi's encryption code. 암호 풀려고. 그 movie U-boat, U2 뭐 그런 잠수함 영화 본 사람. 영화도 안 보니? I know it's a bit old movie, but U-boat, and the U.S. forces, they wanted to steal a small device that do encryption, 암호 풀고 할 수 있는. So that device was very important, and back then the U.S. forces and England was having so much difficulty of breaking it. Alan Turing come up and he break the code using these algorithms. Smart guy. So there is, you know what's a Nobel Prize like in computer science? Turing Award. There is a Turing Award. 아니다. Yeah, maybe Turing Award. There are two. Yeah, Mathematics Field Award. Yeah, field 메달이라고 들어본 사람. 수학의 노벨상. 노벨이 수학을 싫어해서 노벨상이 수학에 빠졌죠. 그런 진짜인지 가짜인지 모르겠는데 컴퓨터 사이언스는 튜링 어워드라고 있어요. 이상한 아저씨들, 천재들 막 머리 이런 아저씨들이 받는. So that is also brief history. This Apple logos, those are the first generations who come up with the algorithms and algorithm way of thinking. So it's a somewhat sad. These techniques were developed to kill people and to win a war. But nowadays, it's in your smartphone. Probably your smartphone is much better than the computers back then that win a war. Anyway, so some guy with the sniper, this very famous guys. Pascal, 혹시 들어본 사람? Pascal, it's a mathematician, right? He's also mathematician and philosopher? 뭐 그렇죠? I don't remember. Pascal, why is popular? There is even a programming language called Pascal, named after him. I actually learned that in my first year school, Pascal language. Anyway, he was also very famous for finding a mechanical calculators. Back then, there is no electric calculators, so something like this. Calculators with the wheels. 실제로 보면 나도 실제로 본 적은 없어요. Never seen it. I've only seen a picture. Sorry, my drawing is not that good. You understand. 아, 이거 잘못 그렸다. 너무 잘못 그렸다. You get the idea, right? 아이씨. Okay, a set of wheels. 1, 2, 3, 4, 5. Oh, 톱니바퀴. Yeah. You're very smart. You get the 톱니바퀴 from this. My drawing is getting better. It's a very similar idea of the algorithm that we looked, carry bits. Maybe after I tweak it 9 times, it's going back to 10. I move this 1. Okay. Mechanical calculator. It's a basic idea. I know it's a very simple example. I'm sure this machine doing much better than this. They can even do multiplications and stuff. Okay. But if you think about it, you can still do this, right? You can still do this. That's one of the. There are many mechanical calculators, not just by the Pascal, but so in order to build that, you also need an algorithm to represent the carry bits and how to represent it. What might be the downside of such devices? like it says, maybe there are limitations of number of digits they can calculate. It says only 6 digits. 6 digits. Maybe they have 6 of this. If they wanted to do a bigger numbers, might need more. But luckily, we're living in software world. We don't need that anymore. But it's very interesting. I had one professor. He's now almost 80, but he's still working. He's from University of Tokyo, Donggyeongdae. But so he's one of the first generation of people who developed these computers. He actually showed me a presentation of explaining how this mechanical calculator worked. He actually programmed the software to demonstrate that. I still don't understand how he did it. 되게 어려워, 실제로 해보려면. I don't understand those algorithms. But it's amazing they come up with this in 19, what? Wow, it's 100 years. So, could solve a polynomial equations and other complex mathematical problems. Polynomial equations. What is polynomial equations? 방정식. 다차 방정식. They could even do that calculators. Why those polynomial equations come up will be covered in probably second. Yeah, we're covering that. Later, we're gonna discuss certain algorithms can do some stuff within a polynomial time or something. We will discuss that later. 잠깐. Okay. 펀치 카드 안 나왔구나. 오케이. After this, blah, 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 tablet, IBM, the guy who founded IBM. What does it stand for, IBM? What is it short for? IBM 뜻이 뭐지? IBM은 다른데, IBM 뭐지? I think it's something called International Business Machineries. I'm not so sure. It's something like business machineries. That's IBM, yeah. Business machineries. Look it up. They actually stand for. But they actually start from other companies, then they change the name. It says it's a programmable card processing. When I was a first year, my school in the first floor had old computers. Computer of size of half of this first floor. We used to call it as red room because the computer was color red room. And you can still do a programmer, but not the typical way of typing keyboard. You have to bring a piece of paper with the punch holes. And then you can actually run, and you try to implement that algorithm on top of the papers, and the computer realizes it and runs. It says punch card. It somewhat looked like this. You can also look it on Wiki. I only tried once punch card for fun. punch card. 여기다 구멍을 내는 거야. They put a hole based on their algorithms and computations. So what I heard is you have to sign up for the time. You have to, I'm gonna use this computer between 9 and 10. And so people write it down like the libraries. So, and the person who's in front of you not finished, you have to wait with this card and waiting to run your algorithm on that big computers. So this is another old timers. It's fun, but you will realize how smart the people was back then. Nowadays, 이거 program is nothing compared to what they have done. No debugging, they have to be precise. 그러니까 구멍만 하면 잘못 들어도 다시 다 뚫어야 되니까. 알고리즘 잘못되고 아니고를 떠나서. So it was a fun times. So I don't care about these big names, but it's something like this. And then Mark I, ENIAC. I think you've probably seen this somewhere in the magazines or probably somewhere in your textbook in elementary school. ENIAC, Mark I, the first generation computers. In next class, I'm gonna show you a small video clip from YouTube, and we're gonna discuss a bit more on that part. But important thing is we did start discussing in the how to thinking for algorithms and how to start writing it. Okay, that's what's count for today. Okay, I'm gonna stop here today. We usually finish around 10-15 minutes before, so you can go to another class. 내가 일찍 끝내는 거 아니야? 학교가 이렇게 하는 거야, 알죠? Okay. About the attendance, I will should call. 한국말 할게요. attendance는 이번 주까지 코र्스 등록하고 나가고 막 이런 친구들이 많아서 있긴 있는데 아직 최종 그게 아니에요. 그러니까 다음 주에도 최종이 아마 안 나올 거야. 안 되면 다음 주부터는 있는 거라도 부를 테니까 그렇게 알고 계시면 됩니다. Okay? Any questions for today? 빨리 가고 싶지? 자꾸 이러면 수업 더 할 거야. 알겠습니다. 수고하셨습니다. Thank you. 네.